In this question from JEST 2022, we have a large system and we add 1 eV of energy to the large system, and it does not change its temperature, but its number of microstates is changed by a factor R. So S is given by S is equal to KB ln omega. KB ln omega. Here KB is the Boltzmann constant and omega is the number of microstates. Now when we add 1 eV of energy, it changes its number of microstates by a factor R. So the new entropy is S prime is equal to KB ln omega R. Therefore we can write S prime minus S is equal to, this S prime can be written as KB into ln of omega plus ln of R. Therefore S prime minus S is equal to KB ln R. Now this added energy, it is actually heat, because heat is defined as the energy transferred between two objects due to transformation at microscopic level, and here the number of microstate is changing, it is a transformation at microscopic level. So the energy in that case is, the energy transferred in that case is actually heat. Delta S is equal to delta Q by T, and in this case delta Q is delta E by T. And from here we have delta S is equal to KB ln R. This implies delta E by T is equal to KB ln R. Delta E is 1 eV, which is joules is 1.6 into 10 raised to minus 19 joule, divided by T is 27 degrees Celsius, which is 300 Kelvin, is equal to KB is 1.38 into 10 raised to minus 23 joule per Kelvin times ln R. Therefore we have ln R is equal to 1.6 into 10 raised to minus 19 joule divided by 300 Kelvin times 1.38 into 10 raised to minus 23 joule per Kelvin, which is equal to 38.647. Therefore R is equal to, we take exponential in both sides, then we will get R is equal to e raised to 38.647, which is equal to 6.08 into 10 raised to 16, which can be approximated to 10 raised to 17. So R is of the order of 10 raised to 17. Here is the correct option.